Let's go to the next column. In this case, when I think about ax squared plus bx plus c, and I look at this, it's like saying x squared plus nothing x minus 25. There is no middle term here with an x without an exponent. That's okay, no big deal. I'm going to put x squared here. I'm going to put minus 25 here. I'm going to leave these two blank because there were no middle terms here to put in these spots. And then I ask myself, what times what makes x squared? X times x. Now, what are my possibilities to make 25? I could have 1 and 25, or I could have 5 and 5. Out of those choices, which choice do I want in order for them to multiply to negative 25, but add up to be 0? I'm going to choose negative 5 and positive 5. If I do that, then x times negative 5 is negative 5x, and x times 5 is 5x. And when I combine my like terms here, don't 5x minus 5x, don't they combine to make 0x? Yes, they do. So if I want to factor this expression, it would be x plus 5, because that is the length of this rectangle, and x minus 5, because that is the width. You could write it with these two things switched. You could write x minus 5 times x plus 5. That's the same thing. This next example has a GCF. Between these two terms, what is the GCF? If you said 2, you are correct. And that is t squared minus 100. If I put the t squared in this portion and the minus 100 in this portion, I'm going to leave these two blank. This is t times t. What times what makes 100? Well, I've got 1 and 100, 2 times 50, 4 times 25, 5 times 20, and 10 times 10. Which one of these choices can I use to put here and here to somehow get nothing as my addition of these like terms? I'm going to choose negative 10 and 10. A negative times a positive is a negative. And then if I have negative 10t here and positive 10t here, the combination of those two is going to be 0. So the factored form of this expression is t minus 100 and t plus 1. T minus 10 and t plus 10. Don't forget to write your GCF in front, always. For the next example, is there a GCF between negative 9 and 49? Well, I really can't have a negative here for my first term. I really want to put a positive term here in this part of the area model. So I'm going to factor out a negative 1. Negative 1 divided out of negative 9 will leave me with positive 9 f squared. And negative 1 divided out of positive 49 will be negative 49. Keeping my GCF in front, I need to figure out what are these two factors. 9f squared goes here. Negative 49 goes there. What times what makes 9f squared? Well, I could put 9f and f here, or I could put 3f and 3f. 3 times 3 is 9, f times f is f squared. And I'm going to choose this one because in every single one of these other cases, it was the same. It won't always be that way, but in this case, I'm seeing a pattern. And then I ask myself, what times what makes 49? I could have 1 and 49, or I could have 7 and 7. And I think by now you'll understand that you need to have one of them to be positive and one of them to be negative, so that a negative times a positive is a negative. So my factors here are 3f minus 7 and 3f plus 7. As you look at the factorization of these three examples, you should start to see a pattern. And I'm going to let you see if you can try and do these last two on your own. And write down what you notice. and then go on to the next video.